Hi, in today's video we're going to take a look at installing index-tts on nixos using a shell.nix file. Index-tts is a text-to-speech model mainly based on XTTS and Tortoise that is capable of zero-shot voice cloning and will work with as little as 4 GB of VRAM. We'll set up a development environment with the Nix shell to install Python, FFmpeg, the cuda toolkit for hardware acceleration, Python torch, and then create a Python virtual environment and install all the requirements needed to install index-tts. Let's get started installing index-tts on nixos using a shell.nix file. First of all, we're going to create a Nix directory in our home folder. We'll do that by running mkdir -p ~/nix. We're then going to change into the directory we just created by running cd ~/nix, and then finally clone the index-tts git repository into that directory by running git clone and the path to the index-tts git repository. Okay, I've switched across to the terminal, so let's create the Nix directory and then clone the index-tts git repository into it. So mkdir -p ~/nix, cd nix, and finally we're going to clone the index-tts git repository by running git clone and then the path to the index-tts.git repository as shown here. Once we have cloned the index-tts git repository, we'll change directory into it and then create the shell.nix file. We'll run cd index-tts, and as you can see here, I've already set this up. We have the shell.nix file and the virtual environment for Python to install all the packages needed. We'll create a shell.nix file in the index-tts git repository directory, and we'll take a look at the settings that we have in it. First of all, we have the build input, which specifies the packages that we're going to install on nixos that are needed for index-tts to run. We have ffmpeg full, Python 3.11, cc, which is needed for building index-tts, cuda toolkit, NVIDIA X11, which is necessary for cuda, and zlib, which is a common dependency. We'll be setting some variables here, which are the LD library path for build inputs, the cuda path to the cuda toolkit, and some extra LD flags for the Linux NVIDIA X11 lib. What we're now going to be doing is taking a look at the shell hook. What we'll do here is export some variables that are needed, such as the language, and then we're going to create and activate a virtual environment. So first of all, we're going to check if the virtual environment exists, and if it doesn't, then we're going to create it by using pkg python 3.11 bin python 3.11 -m virtual environment, so that's VEMV, and then the directory that we'll be creating for the virtual environment is .vemv. After we've done that, we are going to source the .vmv bin activate script to activate the virtual environment. We'll be setting some variables here for cuda, so cuda visible devices equals 1. We'll also be setting the xdg cache home directory, which is where some of the files will actually be stored. We'll then run pip upgrade by running pip install --upgrade pip to make sure we have the latest version of pip. We're then going to install torch and torch audio which are needed for index-tts by running pip install torch audio -- index URL and the path to the wheel file. So at the moment I'm running cuda 12.8. So what I'm doing here is using cu121, and that is compatible with my setup. After we've done that, we're actually going to install index-tts by running pip install -r /requirements.txt, and this will install all the requirements needed for index-tts from the requirements.txt file. Finally, after we've done that, we need to run pip install -e period, and this will finally install the index.tts command so that we can use it. Finally, once this is done, it's going to echo index-tts setup complete. The next step is to run the nix shell in the index-tts directory. I'll switch across to the terminal over here, and we're in the nix index-tts directory, as you can see here, and we have the shell.nix file. So what we need to do is run nix-shell, give it a second. Okay, and what you'll notice is the prompt has changed to green and says nix-shell. Now on your system, this will take a lot longer the first time you do it because it has to download all the files. So it may take an hour to an hour and a half depending on your connection speed. After we've run the nix shell for the first time, it will download and install all the libraries and requirements needed for index-tts. But the next stage is we need to download the models for index-tts. So there are two stages to this. What I found is the GitHub repository will download a config.yaml file in the checkpoints directory. And we actually need to remove that first before we download the models. So what I'm going to do is switch across to the index-tts directory in another shell, because we're going to be using wget, which isn't installed with the nix shell. So come across over here, and what you'll see is a checkpoints directory here. So I already have this set up, so what you would need to do is have a look in the checkpoints directory and see if there's a config.yaml file, and if there is, you want to remove it by running rm-i checkpoints /config.yaml. That will remove the file. We can then move on to the next step, which is to download all the models needed. And we're going to be doing this in the index-tts directory, and this will take a couple of hours depending on your connection speed, because there's about 3 or 4 gig of files that need to be downloaded. And what we're going to be doing is using wget with the -c option, which means continue, so that if the download gets interrupted, you can resume it. So what we need to do is run all these wget commands to download all the files. So I'll switch across and show you the files. I can switch back to this one, checkpoints, and let me do that with the -h flag. So you can see the file size here. So you can see these are all the files we need to download with wget, and these are the couple of files that are quite large, 1.6 and 1.1, 512 meg. There's about 3 gig of files that you need to download before you can actually use index-tts. So that's the next step, is to download all these files, and once that's done, we can actually move on to actually using index-tts. So once you have index-tts installed, the next step is actually using it. Now there's two ways you can do this. You can use the command line, or there is actually a web interface that you can use. but I'm not going to be covering that for two reasons. Firstly, the interface is in Chinese, and secondly, if you only have 4 gig of VRAM, opening up the browser and using index-tts through the browser may just push the requirements over your limit and stop you using the application. So what we're going to be doing is using the command line to process audio. What I'm going to do is go through the options that we're going to be using. So first of all, we have index-tts. This is the command that's going to be installed. We're going to be using. Then in double quotes, we have the text that we're going to actually turn into speech. And one thing I should mention is the punctuation. You can use commas, semicolons, and full stop to create pauses between the words. And the issue is they all have different lengths of pauses they generate. There isn't actually a pause command or a specific option that you can use to set the length of the pause. So it can be a bit hit and miss on how you generate the rhythm using full stops, commas, and semicolons. So what I'm going to do is actually go through these options here. The first most important option is -- device cuda. And what this will do is this will use cuda to process the audio a lot faster than using the CPU. And what you can do is, while index-tts is running, if I switch across to another terminal, you can run NVIDIA SMI, and what you'll see is in the output when it's running, you will actually see index-tts listed. What you can also do is run -- loop. Is it equal 1? Yeah, you can see there equal 1. Quit that. So NVIDIA SMI -- loop equals 1 will loop the output of NVIDIA SMI every second so that you can actually see that the command is using cuda if you want. So the next step is the voice option, and this is the voice that you're going to be using as the cloned input. So this is the audio that is going to be used to generate the voice. What you want to do is make sure that the audio is maybe about 30 seconds to a minute, no longer than that, otherwise it's going to throw an error. And as you'll see here, what we're doing is we're running this command in the nix index-tts directory with the nix shell. And that's why we're specifying an absolute path to the input audio, because we don't want to store the audio in the Git repository, obviously. The next section here, you can see -- model_dir checkpoints. And this is the checkpoints directory here. So that's why we're just using a relative path. You could also put in the full path if you wanted to, because if you wanted to run this command outside of the index-tts directory, you would need to specify the absolute path to the checkpoints folder. And also we have the -- config option here, checkpoints config.yaml. And again, the same reasoning applies. We're specifying a relative directory for the checkpoints config.yaml file because we're executing the script in the index-tts directory. So if you wanted to run this somewhere else, you'd need to put in the absolute path. And then finally, what we have is the output directory. So -- output / desktop output.wav, and that is where it's going to output the cloned audio to. Index-tts records the audio at 2400 kilohertz. So if you want to resample the audio to 4800 kilohertz, you can use FFmpeg to do that. And the reason why you might want to do this is because you want to use the audio in a video project that has the audio set to 4800 kilohertz. So what we can do is run ffmpeg-i input.wav-ar 48000 output.wav, and this will resample the audio to 4800 kilohertz. Now, if you have a lot of audio files that you've generated with index-tts, what you can do is batch process them. So to batch process the audio, we can use a simple shell script like this. And what we do is we create a directory where we put all the WAV files that were created. It's probably best to copy the WAV files just in case anything goes wrong. What this command will do is it will use find in the current directory for all the WAV files, then pass it into xargs, get the input file name with the extension, and it will create a new output file name with the input file name -resample.wav. So if we had a file called example.wav, what it will do is it will create a new version called example-resampled.wav. And you can see the ffmpeg command that it would use here. ffmpeg-i input audio rate 4800 output. And so what that will do is that will go through all the WAV files in the directory and resample them from 2400 to 4800 kilohertz, rather than you having to do it manually one by one. So the next step is to actually, one, find some text that we're going to use for the input, two, a voice that we're going to clone, and then three, create the output. So what I've done is I've taken a transcript from a video by the Magpie Channel TV and created a cloned voice to use with the transcript, and I'll be showing you that next.
So let's dive straight into it then. Newcastle United are ready to swoop for Mark Gahey and Brian Mumo, two massive names, two very important positions that we have needed for quite a while, to be fair. On the right wing thing, fair enough to Jacob Murphy. What a season he has had, stepped up massively.